works best for you individually, this is what you should do. All I did here is said 3 goes into 3 one time, 3 goes into 30 10 times, and that's 10 times x plus 2. And 10 times x is 10x, and 10 times positive 2 is positive 20. And over here, when you do 30 times 3x over 5, 30 clearly is 5 times 6, right? There's a 5 up here, a 5 down here. I'm going to cancel them. 5 goes into 5 one time. 5 goes into 36 times. 6 times 3x is 18x. Now, if you do this like I'm doing it, where notice I didn't write each term out, 30 times this minus 30 times that, you do have to remember you're distributing, so you still have to multiply 30 times that stuff, right? And you have to remember that the fact that there's a 6 here and the 30's crossed through, that's just what happened when I multiplied 30 times this first term, right? I still have to multiply all of 30 times that next term, but when I do, I should see right away that there I can cancel a 2. 30 is clearly an even number, right? 2 goes into 2 one time, 2 goes into 30 15 times. And so what I'm really doing is 15 times x, except it's negative x, right? 15 times negative x is negative 15x. And then I've got to remember I'm doing 15 times negative 3, which is negative 45. But y'all look where I'm pointing. That makes it the negative of negative 45, which is positive 45. And we're at the same point, right? So there's always, almost always, more than one way to do problems. Y'all just have to decide which thing works best for you. Okay. Here's one y'all can practice on. So everybody just take a few minutes and do this. I tried to make it a pretty simple, straightforward one to kind of start us out and just see how we do on this and see if we're getting the hang of what we're supposed to do to kind of get rid of these fractions. I guess I ought to figure it out too. I think what I'm seeing out our window are hurricane bands. Yes. Outer hurricane bands. No, this evening, right about now, I think.
It's already hit.
It has it.
Yeah, it hit around 3 o'clock today.
The eye.
As far as I know, that it started at 3.
Yeah. Well, I mean, I know that by noon the outer bands were starting to hit Louisiana, but
Francie. What? Francie?
Fran.
Francie? Yeah, Francie. Francie.
It's Francie. I thought it was Francine, but maybe you're right. You're probably right.
Yeah, I've been in contact with my little sister. She's over in Louisiana.
Yeah. Yeah, I think the outer bands started hitting them about noon, but I think the eye was supposed to make landfall about now. But anyway, we're getting the outer bands. You can just see them. So you think you've got it? Do you think you have it?
Oh, yeah. I just.
I'm saying, do you think you've got the problem done? Yeah, okay. It's supposed to be pretty simple. So if you're hung up, has everybody figured out what the least common denominator is? 6, okay. All right, let's just go ahead and roll through it. So on this side, if I cancel the 3 on top and bottom, 3 goes into 3 one time, 3 goes into 6 2 times, and 2 times x is 2x. On the other side, I have to distribute. When I multiply 6 over 1 times x over 2, Paris, y'all would say that's 6x over 2. Then you would say 6 divided by 2 is 3. No difference. I'll just say 2 goes into 2 one time, and 2 goes into 6 3 times, and 3 times x is just 3x. And then notice, remember, we're distributing. So we did 6 times x over 2, but we still have to do 6 times negative 2, right? Not 3, because that's what happened when we multiplied times x over 2. And 6 times 2 is 12, but of course, technically that's 6 times negative 2, which is negative 12. And so now we can see, and there's a couple of different ways to sort of bring this to the finish line, but I'm just going to go ahead and say, see if I subtract 3x on each side, 2x minus 3x is negative 1x, or just negative x, and that's equal to negative 12. The reason I moved my x term to the left side, even though it made it negative, is because my constant term was already all on the right. So there's no point in doing extra steps, shuffling things back and back again. I just moved the x term to the other side. Hopefully we see that if negative x is equal to negative 12, then positive x must be equal to positive 12. But that is correct algebraically as well. If it helps you to think of it like this, you could. Remember remember when we talked about, I get lost on what we talked about on Monday night and Wednesday night. Does everybody see that negative x, I could have written here negative 1x if I wanted to, right? Well, 2 minus 3 is negative 1. Y'all see? With me? 2 minus 3 is negative 1. So that's negative 1x. If it helps you to look at it that way, you could do that and say, look, anytime there's a number multiplied times this x term, you divide both sides by that number, right? If I divide both sides by negative 1, well, negative 12 divided by negative 1 is positive 12, right? But the moral of the story is, what I did there is I just reversed all the signs on both sides of the equation. You can always do that, right? The reason is reversing a sign is just like multiplying negative 1 times that thing, right? So if you reverse all the signs on both sides of the equation, it's just like you multiplied both sides times negative 1, and we know that's allowed as long as we do it on both sides. Everybody with me? One more for